It's October 31st, and we're here today at CCNY Chemical Engineering Department with Professor Elizabeth Biddinger. And thank you for coming here, Professor Biddinger, and partaking in this interview. So we're interested in learning more about you, your group, and your work and life here in CCNY.
Mm-hmm.
So can you start out by telling us a little bit about how you got here and what your path was to become professor here?
Sure. Yeah, I joined City College of New York in 2012, and I'm now an associate professor in the chemical engineering department. I started my chemical engineering career as an undergraduate student at Ohio University. That's in Athens, Ohio. And there I kind of really got the passion for electrochemical engineering, doing some work in ammonia electrolysis, and really liked research, so decided to go on to do a PhD. And I did my PhD at Ohio State University, and that's in Columbus, Ohio, also in chemical engineering. And there I worked in electrocatalysis for fuel cells, so trying to replace the platinum in the PEM and direct methanol fuel cells, particularly for the oxygen reduction reaction. And then I was very interested in energy and the environment as well, and interested in going on to a faculty position. And so I needed to do a postdoc, and I went to Georgia Tech, where I worked in a sustainable engineering and green chemistry research group that was half physical organic chemists and half chemical engineers, two different advisors that co-advised everybody, and we all worked together. And so that was a great experience to really expand my research areas. I did a lot of CO2 capture at that time, and working with alternative solvents like ionic liquids. And so then I did the faculty circuit and the whole search, and I found a really great fit at City College. What I was looking for was a place where I could have a nice balance between the research and teaching. And so at City College, we have world-class facilities for our research, and you'll see that later in the video, but in all of our other videos too. And that on top of that, we also still have a passion for teaching. So I teach one course a semester, but I'm expected to do that well. And so I really like that balance, that I had enough time to do the research, the resources and the facilities to do the research, but also still have an opportunity to enjoy that passion in teaching. And so that's a little bit about how I got here. I'm happy to share a little bit about what my research is.
That would be great. That's what I was going to ask you next.
Okay, so here at City College, I work in the whole areas of electrochemical reaction engineering. But what does that mean, really? It means that we're able to approach problems using electricity, which hopefully comes from wind or solar eventually, so that can be decarbonized. And we can address green chemistry and sustainability and energy applications using that electrochemistry. And so we do things such as work with biomass-derived species to convert them to fuels and chemicals electrochemically. So we can do that at ambient conditions, so room temperature and pressure. And we also do CO2 and convert that to fuels and chemicals. We're starting some new work in liquid organic hydrogen carriers to store hydrogen in the backbone of molecules, be able to transport them or store them long durations, and then release it to have the hydrogen back for energy again. And then we're also doing work with alternative electrolytes, sometimes in those reactions, but often in batteries, such as lithium metal batteries, We have work right now with NASA to be able to work in low temperature batteries, so like say negative 40 degrees Celsius, and we're working with ionic liquids and ionic liquid containing electrolytes for those chemistries. And then we're also doing some recovery of metals and both precious and critical materials, for using ionic liquids for extraction and then electrodeposition. So it sounds like we're doing a lot of different things, but we're using the same underlying understandings of electrochemistry and the reaction engineering that goes along with them. And it really is an exciting time to be in this field where we're doing so much about decarbonization, whether it's about the chemical manufacturing itself, the utilization of waste streams to create that circularity, or it's about the energy storage, whether in batteries or in organic molecules.
Good. So has your group set up? How large is it? What type of work do your students do? What kind of instruments do they use?
Yeah, so I have a decent sized research group. I currently have 6 PhD students, a master's student, and an undergraduate student. So I encourage my research group members to work together. So we have some students that are working on the same projects but just different thrust areas or focus areas of the project. My students be in charge of all different types of instruments in the lab. So what it means is that it doesn't mean that if you have, oh, I need to do an FTIR experiment, here, go take my sample. That's not what we're doing. It's making sure that the instruments run properly, that the people get trained appropriately, and that you become the expert source to come to help them. And so even if you're not working on the same projects in the lab, you're working closely with the group on all the different types of instrumentation and techniques that we have. In our lab, we have the ability to do all of the electrochemistry, much of the product analysis, and some of the characterization. We go down to the ASRC, which is the Advanced Science Research Center, Advanced Science Research Center, which is at the south end of our campus, to do more advanced techniques such as NMR, X-ray photoelectron spectroscopy, which is XPS, our electron microscopy such as TM, SEM, and things of that nature. So we have access to all those instruments, but we don't have to be in charge of them, and we don't have to buy them. So that's really a great benefit, and all just we just walk our samples down. So that's great. And it's, as far as my research group goes, as far as how I interact with the students, I interact with my students at least on a weekly basis. Sometimes it can be a daily basis. If we're like really finishing a manuscript or writing a proposal or doing something, but often it's on that weekly to just a little bit more frequency basis, checking in. But I help the students develop the goals that they have and the experiments. But really, I want the students by the end of their time at City College to be able to design their experiments. And I really see that as an important piece of getting a PhD is you have to be able to design your own experiments and be able to direct the research. And so we see that as a process that we grow to as we go through the PhD. Mm-hmm.
And how have your students, they come from different geographical areas, I suspect.
Yep. How
have they adjusted to life in New York City and life in this campus in the middle of Manhattan the way it is?
Yeah. So actually, I love City College of New York and its location. Yes, we have students that are from New York City and the New York area, and we have students from all over the world. Something I love about New York is that it's welcoming to all, because you can find someone with a similarity to you on this campus, and certainly in the city as well. I'm originally from very rural Ohio, and so I wasn't quite sure if I would like New York. I'd only been once, and that was on a high school band and choir trip, and we only went to Times Square to see a Broadway show, and then the Staten Island. I thought all of New York City was like Times Square, and so I thought I didn't want to be here because I thought it'd be like all these like people, you know, like bumping against me and things like that. And then when I came for my interview, I was like, wow, this is Manhattan too. This is beautiful. And you know, the campus itself is really beautiful with the neo-Gothic buildings, but also the neighborhood of Hamilton Heights, where you have all the brownstones and everything. And I personally love the access to all the different types of food in New York City, and the access to the arts, seeing a Broadway show or whatever is happening in the city. It's great. So the challenge becomes balancing high quality research, academic work with all of the great things that are going on in the city. But we can manage. Mm-hmm.
And your students, there are a lot of connections with your students and outside groups. Do they ever get to spend any time in in another environment?
Yeah. So actually, one of my students is currently at NASA's Jet Propulsion Lab in Pasadena, California. He's doing a 6-month internship with them in their working in their battery research and actually doing something for a Venus mission, so which is pretty cool. And so that's an example. Coming up, we'll have opportunities for students to intern at Pacific Northwest National Lab as part of our liquid organic hydrogen carrier work. And we interact closely with the folks at NYU and Columbia within the city. I'm part of the Center for Decarbonizing Chemical Manufacturing Using Sustainable Electrification. We call that DC Muse. And so we have a lot of collaborative projects with that. We had a Columbia student who spent a lot of time in our lab and at NYU. And we are starting to do some of that reverse, going to Columbia and NYU as well. So there are those opportunities, and then it comes with what's the student interested in their research, but also in their long-term career. And it also comes to what are the opportunities that are along with the individual projects. And so certainly having the outside experiences is an important and fruitful part of the PhD program.
And so the students that you've had that have already graduated, can you tell us a little bit where they have wound up? There's not that many of them because you're still fairly young in your career, but the ones you have had that have finished.
So I've had 4 PhD students graduate from my research group. So that was 3 chemical engineers and a chemist. So I have students who are from both chemistry and chemical engineering in my group. And so I have a student who's now a faculty member in Korea. That's where what he wanted to do is he wanted to become a professor back in his home country of Korea, and so he went back there. I have a student who works at Meta, which is Facebook's parent company. She's doing coatings research. She's doing coatings research. So not coating, like the films on glasses and things like that.
Oh.
Yes, it's hard to say, but that's I don't know what it's for. Maybe we're going to have some new vision things through them, maybe. I have a student who is working in sustainability and decarbonization at a small company in New York City. And then my most recent graduate, just this past fall, this fall or late summer, fall. So my most recent graduate, it was the end of August that he graduated. He's going back to Vancouver and going to work in the electrochemical industry there. And so the skills that students gain in my research group are quite broad. So you can work in heterogeneous catalysis and reaction engineering and batteries, in ionic liquids and solvents, traditional process chemical engineering fields, but you can also work in sustainability, decarbonization, environmental activities. Those are some of the core things you can do, but certainly with the set of skills that you build in my group, you can expand much more. We've had graduates from the PhD program go work in finance in New York City, and sure you could do that with the skills you build, with the analytics and things. It's not necessarily what we're getting from our program, but you become marketable in many ways.
And we've heard from some of the prior discussions we've had that there tends to be quite a bit of interaction between the faculty within the department with each other. Do you have a lot of that going on, or any of that going on?
Yes, absolutely. So I have ongoing collaborations with quite a few of the faculty in the department. So I'm part of the CCNY NASA Center for Advanced Batteries for Space. And so that center is led by Professor Rob Messinger, and also has Dean Alex Kouzis and Professor Sanjoy Banerjee as part of that. And so we work together on projects that are all about batteries for extreme conditions. And so the parts that we work on are with low temperatures in my group on lithium metal batteries. But I have a student that is co-advised, so it's primarily in my research group, but co-advised by Rob Messinger, and he's working on lithium metal batteries with ionic liquid mixtures as electrolytes. And then we have the opposite. There's a student that's primarily in Rob Messinger's lab that I co-advise, and that student is working on aluminum metal batteries with ionic liquid electrolytes, so I can help with the electrolyte side of things. I also have a student that is jointly advised between Raymond Tu and myself on working with CO2 reactions with coacervates for looking at novel CO2 chemistries in the mindset of not just CO2 capture, but also valorization of that into high value materials. I also am part of an ARPA-E project on waste to energy processes with Marco Castaldi. He's really doing the combustion and gasification portion of that research, and I'm working on the ash and valorizing the ash. So can we get the critical materials and precious metals out of that ash using the electrodeposition and ionic liquids? And so there's a master's student and that is working on that, and we report back and forth. Those are the formal collaborations we have, but we interact regularly otherwise as a department. I have a number of, they're called shared user instruments that are in my lab, FTIR, chemi and physisorption instruments. Those two were actually purchased as shared user instruments, but live in my lab, so students come and use those regularly. And my students go and interact in the other labs too.
Yeah, I think that's a big strength of this department.
Absolutely, absolutely.
Okay, as we're getting towards the end of it, I'd like you to give us some final comments addressed to any potential students that are out there looking at some of these videos. What kind of message would you like to give? If they're thinking about coming to CCNY, or they're thinking of coming and working in your group, what kind of advice would you give them? What should they think about next?
Yeah, well, City College is a great place. We have many opportunities, and it's really a close-knit community where you can do fantastic research in a fantastic location. So we encourage you to apply. We have a general admission to the department, not to individual research group. So if you reach out to me and say, can I join my research group, I'm not going to be able to make a commitment to that, because we have the whole department makes the decision on who comes to City College. And then about 2 months into your time at City College, then you will be assigned a research group. In between, when you're that new student, what you're doing is you're learning about all the different research opportunities, the different research groups, what are our advising styles, and things of that nature, so that we can find the best fit possible for you. And so what it is take a look. There are a bunch of us that have a lot of exciting research going on. You'll find more than one thing that you would like to do here, and that's great, because that means that you can come in and have those conversations, join the group that fits the best, but also that means that, hey, maybe we have a new collaborative activity that we can write a proposal about, join a project on, or things of that nature as well. So definitely consider City College. We'd love to have you.
Okay. Thank you, Elizabeth, for joining us today. That was some very useful and great advice. So thank you for meeting with us, and I hope this is some value for some of the students out there.
Thank you, and thank you for the interview, and we look forward to checking out the lab.
Okay.